Alrighty. I think, I think that we are live. I'll just chat for a second, give it a few minutes to, not to warm up, but, maybe if someone joins, that would be cool. Let me go to like my live hub. We want to stream in public. Go to, sorry, I'm fiddling in my YouTube dashboard. There it is, view in live control room. Okay, now I can see chat and stuff. Perfect. Okay, so you know what? Let's get something going. Use my new knowledge of BASIC. 10 print. Welcome to the stream. Exclamation point. 20. Go to 10. And then run. So, all right. Yeah. So today, it's going to be basically a continuation of last stream. If perchance you are watching this and you're interested in what last stream was, we've just been streaming. I've just been streaming some learning of the Commodore 64. We're doing Commodore 64 Basic, going through the user manual. I've sort of tongue-in-cheek called it Commodore 64 manual speedrun. I've got like my speedrun timer going there. It's not really a speedrun. I take a lot of digressions, to say the least. Yeah, okay, that's good. I'm checking my OBS scenes right now because last stream I screwed up royally, and I've ended up being muted on one of my scenes. I have this little explainer scene here, and it was not working. It was completely muted whenever I was talking. So I can actually switch back and I can see that the mic is working. I can go to my scene and bam, there's a microphone going there. Thank God. Okay. Anyways, back to scene 1. I see no reason to keep dawdling here. So why don't we just get started? We're doing chapter 4. We're doing advanced basic. And actually here, you know what? Here might be a reason to spend some more time just dawdling, chatting. So, all right, last stream. All right, so here's the Commodore 64, right? So here's what we learned last stream. Last stream, we learned, what did we learn? We learned, okay, whenever you're typing basic, and just last stream, I could not find the home key. That's because my keyboard that I'm using, it doesn't have a home button, or it didn't have a home button mapped. So let me show you the keyboard I'm using. I'm using a Lily 58 trackpad on right side. Okay, it's actually, I think it's this one exactly. I think this is the guy I bought it from, Keyboard Hoarders. It was a good purchase. But yeah, so it has this trackpad over here. But anyway, so yeah, it's not like your standard QWERTY keyboard. And I had to set it up, and I did not have like the home key, but now I have one, and I can do the examples that are in the manual now. I can use all of them, which is great. But so yeah, the home key, what it does is, so you see this cursor, right? It's on the bottom line, bottom left, blinking. All right, I can move it around, moving it up, moving it left, moving it down, right? You can move the cursor around the screen, and then I can just type wherever I want. Okay, this is just how the Commodore 64 works. Well, if I press the home key, right, you can see it took me to the top left. Like that W, it's like blinking now. If I press Shift and the home key, it clears the screen. Bam, beautiful. That's one of the things I couldn't type last time, and I'll show you in this first example in chapter 4 once we get there. So, all right, BASIC is a weird language. Okay, so the first thing we need to know about BASIC is that whenever we're typing it in the BASIC monitor, we have to preface it with line numbers, right? So I can say like 10, line 10, and then I can say print, and then I can say space like subscribe to code orangutan, right? Okay, so that means that on line 10, typed this line. Okay. Now, and then I can say on line 20, go to 10. All right, so this is another feature that isn't really in a lot of modern programming languages. And actually, here's a secret. It actually is still in a lot of programming languages, but it's actually not recommended. It's considered bad coding practice. And quite frankly, I don't know all the reasons why. I couldn't tell you why goto isn't recommended. But anyway, so yeah, goto, basic makes heavy use of the goto. All right, so we can look at this line and we can basic will execute our lines in the order that they're written. All right, and whenever I type like this, if I press enter, it means that I've entered these lines into memory. So I can enter another command like list. Okay, and it lists the code I've written. Line 10, print subscribe to orangutan. Line 20, go to 10. Okay, so I can actually now run this code and it'll just infinitely print subscribe to code orangutan. Bam, beautiful. I can press the escapes key, which is run/stop. And I'm actually interested here. Let's write a bit more of an advanced program in order to, explain basic a bit more. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so we have 14 keys. We have 14 keys, 14 spaces to the right side. So, all right, so we can say list. And then if I want to rewrite a line, right, I can just retype the line number. So that is a neat feature of these line numbers things. So I can say print, or here, what I want to say is I want to for, and you know what, I forgot the for loop syntax. Basic has for loops. They're pretty cool, I guess. Yeah, okay, so for, we'll say sc space count equals, oh shoot. Okay, 10 for sc space. And another thing that's weird about this is that it has mapped, like the F9 key is this up arrow and the F10 key is the equal sign. So I accidentally pressed F8 there whenever I did that, like weird, like, I don't know, big capital EX. That was the F8 key. I don't know what that does, but I'm sure we can learn. So for that equals 1, 2, 7. And we don't have to say a step. We can say, we'll do line 11 because, okay, I can scroll the cursor up. Look, we have on line 20, go to 10. I don't see any reason to change that. We can leave that on line 20. So on line 11, I want to say print, and we'll enter quote mode. And then I'll say, go right with the cursor, 1. Oh, shoot, no, that's wrong. Okay, so, yeah, so I can move the cursor like that. Okay, so I want to say move to the right by 1. So we'll exit quote mode. So now the arrow keys will work to move me around again. Okay, so this weird character here, it looks like an open or a closed bracket, but like, inverted. That means move the cursor to the right. So we can say print, and then I can say on line, and I want to leave some space here. So I'll say on line actually 13 maybe, or we'll say 15. We'll be generous. Print subscribe to code orangutan. Oh, and I want to show one more feature. Okay, so in our basic interpreter, if we want to get rid of characters, we can just type backspace, and we can also just replace characters. All right, and this key here, $, is a shortcut for print. Okay, and then on line, let's say 18, I'll say next, SC, and the default increment is 1. Up here, I could also say for SC equals 1 to 7, I could say step, like, I don't know, 0.3, and it would step by 0.3 every time. But we don't want that. We want it to step by 1. So we'll just use the default. So I'll just say next SC. Okay, and then I'll have it list our program. Okay, so now it has our full program written. So for SC equals 1 to 7, it'll print that. Oh, it looks like it missed our subscribe to Code Orangutan line. So I'll just write that line again. 15 $, print, or no, the $sign means print. Subscribe to Code Orangutan. Now we can list again. Okay, so and now it's in our program. And it didn't expand that line. Wait, did I do it wrong? Let's try it. Run. A syntax error on line 15. Okay, wait, what's the shorthand for print? Oh goodness, I'm already forgetting more basic. Oh, is it question mark that means print? If then I'm going to print yeah, line 20. Oh, okay, so it's not $. Oops. Okay, it's question mark. Okay, so like I said, we can go up here and then I can just replace that. And I'll say enter and submit it. And now we can list again. And you see, okay, it expanded our question mark up here under my flashing cursor at the middle of the screen to the left, and it replaced it with the big print. So now I can say run, and I think it should print. Okay, so it's not doing what I thought it would do. Okay, I don't know why. Okay. 1, 2, 3, 4, 5, 6, 7. I want it to do that before printing. Oh, I know why. Okay, let's look at the program. So my goal was to move the cursor over a bunch, print subscribe to Orangutan, and then loop infinitely. So it would be printing subscribe to Orangutan, but like centered horizontally. But what I've done is I've moved the cursor over and then printed subscribe to Orangutan. And I think actually I need to insert another character which says don't add white space, which I think is semicolon. So I'll edit that line, and then just to be sure, I'll list. Yep, okay, we have our semicolon entered. Okay, so I think I should be able to move this by just saying 9. By just saying 9 there, and then list, and then I think it should have moved it. Yep, okay, so it copied line 15 to line 19, and then if I want to erase line 15, I just type 15 and then enter, and it'll take that as like, oh, line 15 blank. And so next time when I print our program out, it won't list it. Okay, so now let's run. Okay, so perfect. It's printing subscribe to Orangutan, and it's doing it centered. All right, so now let's count the vertical lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay, so there are 25 lines, which means I want to go down 12 first before we do it. So let's print. Okay, so let's do like 5 for DC down count, and it's F8. So, oops, nope, that's F10. It's F10, not F8. Equals 1 to 12. Line 6, I want to print, and then we'll say enter into shift mode or into quote mode, and then I want to go down, which I guess is Q. I don't know about that, but yeah, press the right key. Okay, you know what? I'll trust. And then on line 7, I want next down counter. Oh, and then here we want to make sure we're not doing space afterwards. So, and we'll list our program. Yeah, okay. So it didn't accept it. I have to list, and then I guess I can do that. Okay, now list. All right, so yeah, so now it'll go down 12 lines, and actually we want it to be on line 13, so I guess we'll have to do 13. Let's see if it fixed it. Yep, okay. So let's look at this program now. So it's gonna go down 13 lines to the middle line of the screen, then it'll go to the right 7 characters, and then it'll print subscribe to code orangutan, and then it'll go to line 10. And that's not what we want. And in fact, I want it to be on a clear screen, right? So I don't want it to like go down a bunch and then, it'll be printing on the bottom. So what we'll do is we'll print, and then I told you, on let's say line 4, we can print, and I told you we have our newfound home key. So just to make sure here, we'll exit quote mode, just to make sure I know what key it is. I think it's this key. Nope, it's not that key. Okay, so I think it's like this. Yes. Okay, so it's that key. Goodness, and just, you can't see my hands, but I just pressed the ring finger on my left hand on the home row is where I mapped that to. So quote mode, home, no line break. So then semicolon. Now we'll list our program. And then on line 20, we want it to say go to actually line 4 now. Okay, so let's list our program. So this is the plan. It's going to start on line 4. It's going to clear the screen. It's going to go to the middle line, the middle horizontal line. It's going to move to the right 7 characters. It's going to print subscribe to code orangutan. And then we're going to go back to line 4 in an infinite loop. So, or honestly, it doesn't even need to go back to line 4. We can just do it once. So we can clear 20. Run. Oh, it didn't clear the screen. Oh, I have to press shift. Okay, so you know what? I'll just show you. I can clear the screen by pressing shift and home. Okay, so now we can just fix that. And why don't we clear out the whole line, enter quote mode. Then I'll say home, shift, like that. Okay, there we go. So that looks more right. Enter. Just to be sure, I just like to sanity check. All right, run. Oh, I don't want that ready prompt. So why don't we say 20, go to 4, run. Okay, and I want it to be more stable. I don't know, let's just clear line 20. Maybe we just have to deal with the ready. Run. Okay, perfect. Well, okay, so that's pretty much what I know about BASIC. We also have the if-then statements, but it's pretty simple, I think. You just say, like, I don't know, there's not a good spot for our program here, but we would say, like, if, and then we have a conditional. Oh, and by the way, not equals, it's in most modern programming languages, it looks like this. It looks like exclamation point equal sign. It's not, though. In BASIC, our manual here, it is like this. It's open, alligator, close alligator. It's less than, greater than. So that's interesting. That's an interesting shift up, and I'm sure that'll bite me at some point. But you know what? Let's go ahead and start our speed run back at chapter 4. Now that we've had a little bit of a basic refresher, and let's get to it. Let me start my timer again. Okay, so timer's begun. Let's get back to it now. All right, the next few chapters have been written for people who have become relatively familiar with the basic programming language and the concept necessary to write more advanced programs. Okay, sprite graphics, creating sound, yada yada. Okay, so all right, so it gives us a little example program here, and I want to run this. So all right, we can type in the new keyword. Or actually here, why don't we go home, new, and now if we list our program, we'll see that there's nothing there. So here we go. And so we want 10 rem bouncing ball. And I don't know what rem does. I think it means remark, and it's like a comment. Yeah, line 10 is a remark that just tells the program what it does. It has no effect on the program itself. Okay, perfect. So 10, remark that we're doing a bouncing ball. All right. Line 20, print clear home. So we'll do this. And then I think we want to say, I don't know if it wants us to clear and go home, or if it should just be, you know. So okay, so it says it shows as a reversed heart, and we've seen that reversed heart before, so we can do like that. Okay. Anyways, 20 print clear home for x equals 10. So x equals 1 to 10. We'll do colon, which means new command. We want to print, and then we'll do a new quote, cursor down, close quote, new command, next. Okay, so this is like what we did in our little subscribe to code orangutan example. And actually, here's another thing. We want to insert some space here. And we want to say 2, 5 space. And then I'll say 30, because if I had just run it, it would have just done what it said, right? It would have done immediate mode. It wouldn't have stored the line into line 25. It would have just, you know, done it. Okay, so line 30 for BL, oops, equals 1 to 40. Uh-oh, it says the audio bitrate is 0. What does that mean? Okay, it says audio is broadcasting. Stream status excellent. Here, there might be a little bit of doubling while I listen to this. That's excellent. There might be a little bit of doubling. Listen to this. That's excellent. There might be a little bit of doubling. Okay, so then the microphone does sound kind of peaky, so I turned it down a bit. Okay, so anyways, it's back. All right, sorry for the brief technical interruption. I will make the book bigger and get back to it. Okay. So anyways, back to typing code. 40, print, shift. It says we want a space here. And then we want cursor left. Oh, wait. Shift Q. So Shift Q, cursor left. Shift quote, semicolon, colon, rem is a shift Q. So that's how it wants, that's the little comment syntax in the basic handbook, or in the Commodore 64 handbook. 50. And by the way, whenever I say Commodore 64 handbook, I mean literally that Commodore, the computer company, used to like send you a computer And it came with a handbook that taught you how to program. Like, that's crazy to me. For TM equals 1 to 5. We'll say 60 next TM, 70 next BL, 75, 65, 75, rem move ball right to left, to left, I don't know why I typed list. Line 80, we're going to say 4 BL equals 40 to 1 step -1. Oh, and yeah, here's another example of that step thing I was talking about. So 4, initialize the variable BL to 40 and then to 1, and then step -1. It'll count down from 40 to 1. It's pretty cool. And you can do that in modern languages too, but I still think it's cool. No one ever does it though, to be honest. In fact, I feel like most languages are moving towards like item based. So like for item in list, not really for I equals 0, I less than whatever, I plus plus is like the classic idiom. Like here, I'll type that out. For I equals 0, I guess there's a semicolon here. I is less than whatever. And then I, what layer is it? Plus plus. Yeah, this is like the classic for loop idiom that like they teach you, but people are moving away to it where it'll be like for I in list, where it's like for every item in this list instead of manually plucking the item out using its index, which it's more error prone. Anyway, so line 90, print quote space cursor left, shift Q, cursor left, close quote, no spacing at the end of the line. Enter line 100 for TM equals 1 to 5. 110 next TM 120 next BL 130 go to 20. So now we can see our program in action. Syntax error on line 30. Okay, so let's see our program. Okay, so yeah, all we said is BL equals 1 to 40, and that's wrong. What we want to do is here, we'll insert 1, 2, 3, 4, and I'll say 4. Okay, and then we'll list to make sure it's right, then run our program. So you can see the ball, it's bouncing up and down. Ain't that beautiful? It's kind of flashing in and out. But hey, pretty cool, I guess. I'll be honest, the flashing in and out, it looks good in person. It's a little jumpy, but it's not flashing like it is on the capture card, so I apologize. But okay, we've done some more basic. Beautiful. The program will display a bouncing ball, and it's moving from left to right and back again across the screen. If we look at the program closely, shown on page 44, you can see how this feat was accomplished. Line 10 is just a remark that tells what the program does and has no effect on the program itself. Line 20 clears the screen of any information. Line 25 prints 10 cursor down commands. This just positions the ball in the middle of the screen. If line 25 was eliminated, the ball would move across the top line of the screen. Did I insert that line? Wait. Huh, I guess I didn't. Oh, because that was the line that I messed up. So yeah, oh, here, we'll add that in. For 1 to 10, print quote mode, cursor down, exit quote mode, next. 25, okay, what did I do? Oh, okay, yeah, line 25 for, what is it? X. Yeah, so I have to insert 1, 2, 3 characters. We'll say X space, and then it's like that to type the, oh no, it's not. Shift, insert that to type the equal sign, and we'll say shift, insert one more time, just add some spacing. There we go. Okay, now maybe you run. Okay, so now it's across the bottom of the screen, which looks kind of weird. It's supposed to be the middle of the screen. Here, wait. Let's start program one more time. 10 rem bouncing ball, 20 print heart, for x equals 1 to 10, print cursor down, next. What? You know what? I guess, man. I guess. Why not? I also want to see what it would look like without clearing the screen, because I think it'll just draw like a diagonal zigzagging shape. So, I guess we'll have to, we'll say go to 25 instead, or 130, go to 25 and run. Oh no, it's not. That's not how it works. I was wrong. Anyways, I don't really care to, create that effect, but we could easily make it print out, a zigzag across the screen, and then what is it? Shift, bam. Okay. Anyways, let's go back to reading the program. Here, we'll get it up on screen, and it's a little wrong now, but don't worry about that. Line 30 sets up a loop for moving the ball 40 columns from the left to the right. Line 40 does a lot of work. It first prints a space to erase the previous ball positions. Then it prints the ball, and finally it performs a cursor left to get everything ready to erase the current ball position again. The loop setup in lines 50 and 60 slows the ball down a bit by delaying the program. Without it, the ball would move too fast to see. Line 70 completes the loop that prints balls on the screen, set up in line 30. Each time the loop is executed, the ball moves another space to the right. As you notice from the illustration, we have set up a loop within a loop. This is perfectly acceptable. The only time you'll get in trouble is when the loops cross over each other. It's helpful in writing programs to check yourself as illustrated here to make sure the logic of a loop is correct. To see what would happen if you cross a loop, reverse statements in lines 60 and 70. You will get an error because the computer gets confused and cannot figure out what's going on. Lines 80 through 120 just reverse the steps in the first part of the program and move the ball from right to left. Line 90 is slightly different from line 40 because the ball is moving in the opposite direction. Yeah. And when that's all done, the program goes back to line 20 to start the whole process over again. Pretty neat. To stop the program, hold down restore and hit run/stop. I don't know what restore is, but whatever. That doesn't matter. Oh. For a variation of the program, edit 40 to read, and that creates like a pyramid, but I don't care. Let's say new. And then also clear the screen. We have a new programs, right? We're gonna learn user input. Ha ha ha. Okay. Um, 10 input A, oh goodness, A $, 20 print you typed a $. 30 print, I assume that just prints a blank line. 40 go to 10 run. Code orangutan. Whoa, you typed code orangutan. Print subscribe. You typed print subscribe. Wubba bubba. You typed wubba bubba. Beautiful. What happens when you run the program is simple. A question mark will appear, indicating that the computer is waiting for you to type something. Enter any character or a group of characters from the keyboard and hit return. The computer will respond with you typed blank, followed by the information you entered. This may seem very elementary, but what you can have the computer do, but imagine what you can have the computer do with any information you enter. You can input either numeric or string variables and have the input statement prompt the user with a message. The format of input is input prompt message, semicolon variable, or just input variable. To get out of this program, hold down the run, stop, and restore keys. Oh gosh, I don't know what run/stop is. Okay, let's go to our looking up screen. Commodore 64 run/stop. Okay, shift run stop might be the answer we're looking for. So shift escape. No, that's sys. Okay. Where is Commodore 64 restore key on Mr. FPGA? F11. Okay. I don't buy it, but let's see. F11 escape. Yeah, that did nothing. Maybe I can get it to crash. Okay, it didn't do that. Oops. Scene 2. Updated keyboard to allow for configuration in original layout or symbolic. Okay, so it looks like there's an open PR for this. Does it work, I wonder? I don't know. I might try this fork at some point. Keymap Commodore here. Where is restore? Run stop restore. Oh god, I don't know where the hell that is. Although yeah, so that would make sense because like, so that's F9, F10. Okay, so here's my theory actually, is that this would work, but my keyboard isn't currently mapped. So you know what, here, I told you that I'm using a Lily 58. Why don't we take a brief excursion and configure it? So I think I have in my downloads, yeah, I have Vile installed. So here. Let's plug in the USB cable for this, and I need an open USB port. Okay, I unplugged the mouse. But okay, yeah, so here we have Windows Shift to workspace 6. So I have a bunch of virtual workspaces. So like that's 6, that's 7. We're on 2. Okay. So all right, so what this says, this is my first layer. So like this is just like normal typing. And it's saying that F11 plus the escape key and here. Is it like that? Click. Shoot. I recently set up a little key. Yeah, okay, so it's so I told you, yeah, so here, look, there's a trackpad on the right side of the keyboard. But you can't really press and hold with this trackpad because all it does is it shows you like, oh God, all it does is it shows you. Oh yeah, you can't click on this trackpad because all it does is show you. Like all you can do is like move the keyboard around. You can't actually, click with it. But that's not a big deal. So because all I did is I set up on this layer a way to emulate left click button with this. So I can like press down my layer key, which is this guy right here. You can see it on that side, layer key, and then I have my little access to my click right here on my middle finger. Anyways, so yeah, so whenever we're on the layer with the function keys, we no longer have access to run stop because we lose our escape key. So let's see what that's called. KC escape. So all we'll do is map that to KC underscore escape. Okay. And then that should be good. So we can test it by typing hello and then escape, escape, escape. Perfect. It works. So we can just say close that window, and then I'll plug in the keyboard back to the Commodore. All right. Okay, so now it's working. And so I should be able to press layer 2 and F12. Okay, so layer 2, oh shoot. F11 escape. Oh gosh. Okay, well, it's not working. So, all right. You know what, here, we might have to just reset and just have to move on with our lives. Oh, sorry, you couldn't see that. So yeah, it's not working. F12 opens up the menu, but so what I did is I just opened up the menu and went up here to reset. Anyways, let's go to. Let's just keep working. Okay. So I unplugged my mouse. My mouse isn't working. Let's plug the mouse receiver back in. I'm using like a Logitech, the little Logitech nub receiver. All my other USB ports are taken by the capture card and by, goodness, my mic. Okay, so we have a nice little program here. So we'll say one rem. Oh, and here we'll make sure we just say, because if we say list, yeah, we have nothing loaded. Oh yeah, because I reset. One rem temperature conversion. Oh, interesting. Conversion program. 5 print, and we want, oh gosh, I forget the key. Like that. Yep. Print clear home. And print convert from Fahrenheit or Celsius space paren f/c close paren next line or new command. It says no space there. Okay. Just input a $. 20, line 20, I'll say if a $, equals, oh, that's not where it didn't want space, whatever. It wanted this empty space. Then 20. So yeah, this is the if syntax. It says if conditional, then, and you enter a line to go to. So, and it'll just, like I said, it's then 20, it just goes back. That feels like a bug. Shouldn't it go back to, I feel like it should go back to line 10. Oh well. If a $, equals, there we go. So f, then go to line 100 and 40 if a $, doesn't equal C, then 10. Okay, odd, but whatever. 50. Input, we'll say enter degrees Celsius. Oh, and we want, we want like that. C, so it'll go into variable C, and actually semicolon C. Then on 60, we'll say F equals paren C, C times 9 divided by 5 plus, plus 32. Line 70, that's 60, line 70, print C, semicolon, quote, deg Celsius equals space, quote, shift space, quote, semicolon, F, semicolon, quote, deg dot Fahrenheit. Line 80, I just want to print a new line, then go to, line 90, go to 10. Line 100, we want to input, enter degrees Fahrenheit, colon, space, quote, semicolon, F. Line 110, C equals, finally getting that muscle memory down, F minus 32 times 5 divided by 9. That's 0. Divided by 9. You can see that's just the inverse of that little formula that we did up there. So pretty good. It's a standard, like conversion formula too. Print F semicolon quote deg fair. Oh gosh, I misspelled Fahrenheit. I've been misspelling Fahrenheit the whole time. It's F-A-H. Ren. Right. I'm such a fool. Okay, line 120. I'll fix that in a second. Equals quote semicolon C semicolon quote deg dot Celsius. And oh my god, I keep misspelling Celsius too. Why can't I spell, man? That's messed up. Line 130, print 140, go to 10. All right, so let's just fair embarrassment. All right. Convert from, and we want to insert here, so shift H, Fahrenheit, or Celsius with an S, and then enter degrees Celsius, degrees Celsius, shift insert Fahrenheit. Oh man, this is so embarrassing. So that I can't spell, man. Oh well. Fahrenheit, Celsius. All right, let's list Fahrenheit or Celsius, degrees Celsius, degrees Fahrenheit. Okay, let's see if it runs. Let's see if I didn't make any more mistakes. Okay, so you'll see input in action. So if F is typed, Fahrenheit, so let's say we convert, let's say 70, 21 degrees Celsius. Fahrenheit or Celsius, so let's say Celsius. 89 degrees Celsius, or here, 100 degrees Celsius is 212 Fahrenheit. That sounds about right. And let's do it in reverse. Make sure it's the same. Fahrenheit 212 is 100 degrees Celsius. Perfect. Perfect, perfect, perfect. Now let's stress test it. Say Fahrenheit, let's say negative 19. Okay, negative 28 degrees Celsius. Yeah, let's say Celsius. Let's give it 32. It should give, oh goodness, no. Celsius, let's give it 0, and it should give us 32 Fahrenheit. So it handles negative numbers. How does it handle decimals? 85.4. Okay, and it handles them just fine. Because if we, oh gosh, there's no way to stop our program. Man. Shift escape. Sys. Maybe it's one of the other function keys. Let's just try them all. Function escape, man. I'm so sad that didn't work. Well, we can't stop, but let's see what happens if I type in like A. From Fahrenheit or Celsius. So it's just typing in nonsense. So I have to type in F or C, and then what if I say like A? Redo from start. Redo from start, redo from start, redo from start. Fungus. 0, 9. Okay, yeah, so it works if I do that. All right. Line 40 does one more check. This may seem like a lot of detail, but it is good programming practice. A user not familiar with the program can become very frustrated if it does something strange because a mistake was made entering information. Once we determine what type of conversion to perform, the program does the calculation and prints out the temperature, entered and converted the temperature. The calculation is just straight math, using the established formula for temperature conversion. After the calculation is finished and answer printed, the program loops back and starts over. After running, the screen might look like this. So yeah, that's what the screen did look like. All right, so oh man, we'll have to reset. That's so frustrating. I need to get that figured out, but honestly, I don't care to try again that badly. Okay, so we don't need to type new. The list, nothing's there because we reset the program. Print. Man, it's like every 4 minutes says the bitrate is 0. Stream settings. No, nothing, nothing, nothing. Oh well. All right, so one print shift layer home 10 get a dollar sign if a dollar sign equals blank, then 10 20 print a dollar sign 30 go to 10. I guess run now. Hello. The prompt is blank. And I can just type whatever I want. Okay, so here's the thing about the Commodore 64 keyboard, right? So I can type all these normal letters. Let's just look at the top row. QWERTY UE up, or I messed up. QWERTY UE up. All right. If I press shift, we get a bunch of different symbols. Yup. And we can look at the rest of them too. HJK semicolon. C Z ZYXW B MN something question mark, sure. Anyway, so yeah, so there's all these symbols. Run, stop, and restore. Man. Oh. Oh, what? How did I stop that? Wait, I did something. Here, wait, run. Let's do key combinations again. So I'm in the program. I just have to press them both at the same time. I don't have to press and hold one of them. Okay. Okay, cool. We figured out run, stop, and restore. Awesome. Okay. Oh, what? Load the temperature conversion program? Wait, was I supposed to save it? After running the program, make sure to save it on disk or tape. Oh no. Oh well. We can just skip through here. So get a dollar sign if A is blank, then 20. And then if A doesn't equal C, oh no. Oh no. Here, okay, wait. So I know there's like virtual disks. We can mount something there. Like an empty D64. And then, man, okay, let's go back up. Oh man, I might have to backtrack in my speedrun here, and I might have to go back and learn how to save programs. Not a big deal. if I do, but whatever. Much to learn, much to learn. Okay. Let's honestly, whatever. Let's just keep going. And if it has us like save and load a program one more time, then let's let's we can go back and relearn that. Random numbers and other functions. Okay. Commodore standard library stuff. Beautiful. The Commodore 64 contains a number of functions that are used to perform special operations. Functions could be thought of as built-in programs included in BASIC, but rather than typing in a number of statements each time you need to perform a specialized calculation, you just type the command for the desired function and the computer does the rest. The computer does the rest. Okay, yeah. Many times when designing a game or educational program, you need to generate a random number. To simulate the throw of dice, for example, you could write a certain program. You could write a certain program. You could certainly write a program, wow, that would generate these numbers. But an easier way to call upon the random number function. To see what R&D actually does, try this short program. Okay, so new, goodness. 10 for X, oh gosh. All right, 10 for X equals 1 to 10. 20, 20, print R&D 1, comma, 30 next. Okay, so here's one thing to note, is that this comma character up here in our program, where my cursor is flashing, that means like, so the Commodore 64 has, it's 40 characters wide, right? Each line that I'm like scrolling through is 40 characters, and you can automatically tabulate information basically into like a specific, it's divided into 4 groups of 10 spaces wide. So like here, we can, I could say 10 for X, goodness, equals, I never remember that, where the equal sign is, to 10. 20, print, we can just say, goodness, harangue 10, and that should be, how long is that? ORANGUTAN. That's 9 characters. Beautiful. Comma, which says put these in the groups of 10 characters, and say 30 next, and then say run. See, okay, and it did that. It placed it into 4 columns of 10 characters. And if I want more, I can say like 10 for X equals, gosh, I never remember that, equals 1 to, let's pick a nice round, multiple of 40. I think it's 25 lines wide, so let's say 100. For X equals 1 to 100 list. Next error in 10. 10 for X equals 1 to 100. Run. Okay, yeah, so I don't know what didn't work there, but yeah, we can print a full screen of orangutan. Anyway, so that was our random number function. So here, let's change it back to the random thing just so we can see. List, we'll say 10 for X equals 1 to, and let's say 12, 20, print RND 1, comma, run. Okay, and then it says we want to run our program a few more times to see if they're all different. And yeah, we can see that these are indeed random enough numbers. I wonder what random number generator the Commodore 64 uses. Yeah, that'd be interesting. After running the program, you will see a display like this. Your numbers don't match? Well, if they did, we would all be in trouble, as they should be completely random. Try running the program a few more times to verify that the results are always different. Even if the numbers don't follow any pattern, you should start to notice that some things remain the same every time the program is run. First, the results are always between 0 and 1, but never equal to 0 or 1. This will certainly never do if you want to simulate the random toss of dice, since we're looking for numbers between 1 and 6. The other important feature to look for is that we are dealing with real numbers with decimal places. This could be a problem since whole integer numbers are often needed. There are a number of simple ways to produce numbers from the RND function in the range desired. Replace line 20 with the following and run the program again. So we're going to replace line 20 with 20 print 6 times RND 1 in parens. Okay. And interesting how mine displayed in columns. Oh, actually, I know why. So for some reason, my DOS prints numbers on this line here. It prints numbers with the space ahead of them. And in fact, I'm on, not an emulator, but I'm on a simulator, so I can easily switch stuff out. So what if we try that? What if we try hardware, system ROM loadable C64. Yeah, loadable standard C64. Yeah, wait, I don't know. What the hell does that do? Reset. Commodore 64 basic V2. Wait, it's no longer says Dolphin DOS. Okay, wait a second. We might have been able to go back to standard Commodore 64. Okay, wait, let's write that quick program again. Okay, 10 for x equals 1 to 12, 20, print 6 times RND prints 1, 30, next, run. Okay, so it's still printing with a space ahead of them. Why do my numbers print? Oh, I didn't insert, I didn't put a comma in. 20, print 6. That might have been the issue the whole time. RND, that's so stupid. RND 1, comma, run. Okay, so yeah, now we have a column of 2. Oh, how silly of me. Oh well. Oh well. Okay. So that cured the problem of not having results larger than 1. But we still have the decimal part of the result to deal with. Now another function can be called upon. The integer function converts real numbers to integer values. Once more, replace line 20 with the following program to see the effect of the change. So 20 print, and then we'll say int function call, parentheses. Shoot, oh gosh, 20 print int, and what happened there is, so again, non-standard keyboard. The way I have mine set up, this right thumb here is the enter key, this left thumb is the space key, and I get them confused because on my normal laptop keyboard, I press space with my right hand, not my left, and switching to my left hand on this thumb key, it's been tough. Anyways, print int 6 times RND run RND 1 paren run. Oh gosh, let's do the comma again. I'm so foolish. Or no, here, let's list. We can just insert it like so, comma, enter. There we go. Okay. And those are all, that's a lot of 1s I'm seeing. Okay, that's just a fluke. That's to be expected with randomness, I guess. That took care of a lot, getting us closer to our original goal of generating numbers between 1 and 6. If you examine closely what we generated this last time, you'll find that the results range from 0 to 5 only. As a last step, add a 1 to the statement as follows. So list int, and let's say +1 comma list. Now run. Beautiful. Now we're getting numbers from 1 to 6. It's just like a little d6. Now we have achieved the desired results. In general, you can place a number variable or any basic expression within the parentheses of the int function. Depending on the range desired, you just multiply the upper limit by the R&D function. For example, to generate random numbers between 1 and 25, you could type 20 print int 25 times R&D 1. So yeah, let's just change this to insert 2, make it 5, enter. And now we're getting numbers from 1 to 25. Let's see if we can roll a 25. There we go, there's a 25. Let's see if we can get a 25 and a 1 in the same screen. There we go. There's our 1, and then there's a 25 at the top left, but there's another 25 right there. Beautiful. And then the basic handbook gives us a nice little formula for getting the number. Since we've gone to some lengths to understand random numbers, why not put this information to use? The following game not only illustrates a good use of random numbers, but also introduces some additional programming theory. In running this program, a random number nm will be generated. Oh yeah, here's another thing about basic, right? So let's clear the screen. Okay, so let's look at this program that we have. For x, our variable x, that's very standard for for loops, right? Short variables. Well, I'll say modern programming practice told us that we usually want long variables. So let's say we wanted to change this program to like input give me your SSN, and then we'd save it in SSN $. Okay, well, suppose we wanted to use this variable again. We can actually refer to it as SS. Clear 30. No errors in text line 10. Oh no. Oh, I think, oh, it's a semicolon right there, not a comma, isn't it? And we can say like a 5. Okay. Now you see here in my program, and let's so in this program, I called the variable up here SSN, and then down here I referred to it as SS. Okay, this is because in BASIC you can only the first 2 letters of variable names actually matter. So SSN is actually equivalent to SS, like here. I think I could actually change this to SS fries and a drink $. Oops, $. Yeah. Type mismatch error in 20. Oh no. Wait, maybe it's not equivalent, and maybe I'm a fool. Type mismatch error in 20. Okay, you know what? I might just be a goober. And more than the first 2 letters matter? Maybe the variable name is too long. So here, maybe it's actually print SSA. Run. Yeah, okay, so yeah, so you see, we stored the variable in SSN, and then we printed it in SSA, but that obviously, it doesn't work. It doesn't, it worked, and it shouldn't have in like not normal, but in a modern programming language. This is because BASIC only cares about the first two letters. And to tell us it's a string, it has this $sign at the end as like the little type indicator. So anyways, so we want to make a new program here according to the book. So we'll say 1 rem number guessing game, 2 print the classic. I feel like we're gonna be typing this a lot. Print reverse heart 5, and that clears us and puts the cursor back at the home. Input enter upper limit for guess li 10 nm equals int li star rnd 1 plus 1. Okay, so I told you just a second ago that BASIC does types, right? So like a string versus like a number with decimal places, like a float, versus an integer, which is just a number with no decimal place, like 0, 1, 2, 3. Those are integers. It tells the difference between them, between like a string, like some words, versus a not string. It tells the difference between them using a little suffix. So li tells us it's like a floating point number, and $sign tells us it's a string. So 10. Okay, so 15 cn 0. Oh shoot. Equals 0. 20 print. Oops. And oh gosh, I don't know where the single quote is. Huh. It's stored somewhere over here. Where are you, single quote? That's good enough. Apostrophe, what was that? Oh gosh, 20 print. Apostrophe 6, yeah, sure. I've got the number. Print 30 input. What? Oh, what did I say? Apostrophe 6, yeah, or shift 6. What's your guess? Close quote, semicolon, goo. Oh goodness. Oh goodness. 35. 35. We're gonna have to read this program again just to make sure we have all of the lines correctly, man. I keep making typos. Cn equals Cn plus 1. 40 if goo, which is I guess, is greater than nm, then print my number is lower. Print go to 30. 50 if goo is greater than nm, then print, goodness, my number is higher. Print go to 30. Now on line 60, because I assume the winning case, print great. You got my number. 6. Oh god. Oh no, I cleared line 5. Okay, let's retype line 5. 5 input enter upper limit for guess semicolon li. And actually, okay, if we look up here, we actually see I did a typo where I had colon and it should have been semicolon. So oopsie daisy. 65 print in only space quote semicolon cn semicolon guesses print. Then we'll say 7. We'll say 70. Man, keep telling me I keep pressing enter on accident. And in fact, just to like declutter the screen, let's go home and then list our program. Okay, that looks fine enough. 70 print. Do you want to try another? Question mark? Y/n. And I'm diverging from the program a bit, but I want to add the question mark because I think it looks nicer. Semicolon. And then line 80, we want to say get an is answer, I assume, $sign. So $sign means get an as a string. If an $sign goodness equal equals quote nothing, then just stay on line 80 and keep looping forever. 90 if an equals y, then 2. Yep, then we'll clear screen and start again. 100 if an $sign equals, oh, if it doesn't equal n, then go to line 70, and then it's just going to fall through if it does equal n to ending the program. All right, let's try running it. Enter upper limit for guess. All right, so let's be kind to ourselves and let's say like 5. I've got the number. My guess is 3. Great, you got my number. Oh god, that's so silly. Yeah, okay, let's try again. Okay, let's be a little bit harder. 11. Okay. 6. My number is higher. Okay, so between 6 and 11, let's try like 8. My number is lower, so between 6, 7, and 8, 7 only. You've got my number in only 3 guesses. Then we can say, if I say no, it takes back to ready. Oh, beautiful. Okay, yep. I don't need the explanation. In lines 40 and 50, a colon is used to separate multiple statements on a single line. This not only saves typing, but in long programs will conserve memory space. Also notice the if-then statements on the same 2 lines. We instructed the computer to print something, rather than immediately branching to some other point in the program. The last point illustrates the reason behind using line numbers in increments of 10. After the program was written, we decided to add the count part, by just adding those new lines at the end of the program. At the end of the program, numbered to fall between the proper existing lines, the program was easily modified. The following program simulates the throw of 2 dice. You can enjoy it as it stands or use it as part of a larger game. Okay, so Yeah, why don't we clear that last program and say 5 print care to try your luck. And okay, that's odd. How did it get lowercase? I guess we'll have to Google that. How to type in lowercase on Commodore 64. Shift Commodore 64. Shift Commodore key. Oh god, what's the Commodore key? Let's look at this key map. It's to the left of the spacebar, which I guess is usually the Alt key. So Shift Alt. What? That changed the whole screen. I mean, what? So if I type in like that, what? Default. Dumb question. Printing CHR14 or equivalent, pressing Control N in a context where you type is echoed to the screen. Okay, so maybe let's try doing that again. Print Control N. Care to try your luck? Run. Okay, let's retype that because now we can say print Control N. That's Control V. Control N. Care. Or no, we want to say. Actually, here. We're gonna assume that we're in. Oh god, what was it? It was Alt. Oh god, it was Alt something. Oh, Shift. All right. Okay. So Shift Alt to go to back to caps mode. So I'll say 5 print. I don't know if this will work. C Control N. Enter quote mode. Control N. Delete. Okay, close quote mode. Go over. I want to insert the letter C here. Oh gosh, I'm so bad at typing, man. Care to try your luck? Question mark. And then Control N. Oh shoot, it's not N. Control N. Quote. Control N. Close quote. Backspace. List. Okay, so there we go. Honestly, let's see if that even prints correctly. No, it doesn't. All right. Okay, let's go back to normal mode. Let's read this Reddit thread. If you want the hello world to contain mixed case, you have to be in the mode where everything is lowercase, which means the basic program will look like this. The print has to be in lowercase because the lowercase letters in text mode are the same characters as the uppercase characters letters in graphics mode. Which is why whenever lowercase exists at all, your programs and the ready prompt and the startup banner are all lowercase. If they were uppercase in text mode, they'd be unreadable collections of graphic symbols in the startup mode. In graphics mode, the capitalized version of your program becomes 10 yada yada hello world, which BASIC doesn't understand any more than you do, even if you happen to have a font with support for these Unicode characters, which you may not since they were only added last year. So in lowercase mode, I can do Shift H. All right. Okay, so 5 print, and you know what? Just to make sure you guys see this. Like, okay, so you see what I'm trying to type here is on the right side of the screen in like the little banner. Care to try your luck? For some reason, it has lowercase letters, and I don't know why, and it doesn't explain how to get lowercase letters. Maybe it did and I skipped it. Did it say it ever? Lower range? No, it literally hasn't said how to do lowercase letters. It just threw them in there. Okay. Bam. Let's enter into lowercase mode, and I can say Shift. Care to try your luck? And print red dice. I guess this wants to be in caps. Red dice 1, 2, 3 equals int 6 times RND 1 plus 1. There 20 print white, I guess all caps, white dice equals int 6 times RND 1 plus 1, or parentheses plus 1. 30 print. No, okay, I'm gonna be honest. I think this was just a little typographical error from the Commodore people, but I'm gonna treat it as if it's real. Hit space bar for another roll. Print 40, get a $, if a $, or oh gosh, 40, get a $, if a $, plus equals, I don't know why I put plus there. All right, I actually do, but it's because when I'm typing normally on like my laptop, not, on a Commodore 64 simulator, that's where the equal sign is located usually. A $, equals sure $32, then 10. Run. Just care to try your luck? What are we trying on for? Like, I know what's going on, but whatever. New, and let's say get out of lower. Oh yeah, so see, lowercase mode, uppercase mode, lowercase mode, uppercase mode, lowercase mode, uppercase mode. That's trippy. All right, let's bang, bang, bang. All right, so now we're back at the top of the screen. Print, pen print, clear home, close quote, bam, 20, print, sure, dollars, oh gosh, $sign, 205.5 plus R&D 1 semicolon 40 go to 20 run. Oh, there we go. This is I think they call this little one-liner the maze generator. Isn't that pretty cool? There we go. So now we're generating a little maze using it's not a very great maze, but it's still a maze. So as you may have expected, line 20 is the key here. Another function $, character string gives you a character based on a standard code number from 0 to 255. Every character the Commodore 64 can print is encoded this way. See Appendix F. To quickly find the code for any character, just type print ASC X or whatever character, where X is the character you're checking. This can be any printable character, including graphics. The response is the code for the character you typed. As you probably figured out, ASC is another function, which returns the standard ASCII code for the character you typed. You can now print that character by typing $X. If you try typing print $$ 205 semicolon $$ 206, you will see two right side graphic characters, M characters on the M and N keys. See the two right side graphic characters on the M and N keys. And these are the two characters that the program is using for the maze. By using the formula 205.5 plus R&D1, the computer will pick a random number between 205 and 206.5. There's a 50-50 chance of the number being above or below 206. $$ ignores any fractional values. So half the time the character with the code 205 is printed, and the remaining time code 206 is displayed. If you'd like to experiment with this program, try changing 205.5 by adding or subtracting a couple tenths from it. This will give either character a greater chance of being selected. So what is it? We can say just throw in a breakpoint. List. So let's add, or let's just change it to like 0.4, and we can bias it towards one direction. Just run. So now I think it's biased towards like the / character. Let's do something more extreme. List like .1. Yeah, so that definitely biases it way towards the / character, which does look pretty cool. Or not /, but it's like the back dash. I do kind of like it, but whatever. Yeah, that's pretty cool. Okay. Oh, and that's through chapter 5, advanced color and graphics commands. Ooh. All right, so I'm actually going to leave this up for a second, or actually no, I'll go to BRB, but because I have to pee, so I'll be right back. All right, I'm back, and real quick, let's change the chapter heading. Properties, chapter 5. Okay, so I don't think we'll get through the entirety of chapter 5, but let's try our best. It'll be good. Up to now, we've explored some of the sophisticated computing capabilities of the Commodore 64, but one of its most fascinating features is an outstanding ability to produce color and graphics. You've seen a quick example of graphics in the bouncing ball and maze programs, but these only touched on the power you command. A number of new concepts will be introduced in the section to explain graphic and color programming and show how you can create your own games in advanced animation. Because we've concentrated on the computing capabilities of the machine, all the displays we've generated so far were a single color, light blue text on a dark blue background with a light blue border. In this chapter, we'll see how to add color programs and control all those strange graphic symbols on the keyboard. Gotta drink some more water, man. Yummy. Okay, printing colors. As you discovered, if you tried the color alignment test in chapter 1, you can change text colors by simply holding the control key and one of the color keys. This works fine in the immediate mode, but what happens if you want to incorporate color changes in your programs? When we showed the bouncing ball program, you saw how keyboard commands like cursor movements could be incorporated within print statements. In a like way, you can also add text color changes to your programs. You have a full range of 16 text colors to work with. Using the control and number key, the following colors are available, and I wonder if I can get them to print while I'm like doing this display. So 1, 2. Okay, yeah, so I have to stop this. All right. Control 1, black. Control 2, white. Control 3, red, and red looks really bad for you guys, and honestly for me too. Control 4, cyan. Control 5, purple. Control 6, green. Green looks pretty good. Honestly, the blue looks the best on capture card. Control 7 is dark blue. Control 8 is yellow. And then Control Alt 1, that says orange. Control Alt 2. Oh, that's, no, wait. Control C key. It's not working. Alt. Might have another case of, the old, gosh, the run stop key. Like, yeah, you have to like type it in rapid succession. Oh, wait, maybe that worked. Yeah, that got us to light red. Yep, okay. I have to press I have to press like, yeah, I have to press the C equals the Commodore key and then control 1 very rapidly. Anyways, let's go to brown. Oh man. Oh wait, what? Pressing the key right above control is working tremendously well. Anyways, okay, so 1 is orange, which also looks bad on capture card. That's brown, which looks horrendous in both capture card and real life. Light red looks quite good. 4 gives us gray 1. 5 is gray 2, which looks really good on both. 6 is light green, which it's a bit bright. 7 is light blue, which I think is just the default, yep, the default background color. And then 8 is a third lighter gray. Yeah, so wait. So we have like the gray or the white. We have light gray. We have, what is it? Oh, no, that's green. Oh, that's light green. So that's gray 2. Gray 1. And then control 1 is black. So that's a nice little gradient that we get access to. It's pretty cool. Let's go back to 7, or yeah, the default. Okay, type new and experiment with the following. Hold down the control key and at the same time hit the 1. Next, hit R key without holding down the control key. Okay, so 10 print control 1 R control 2 A control 3 I control 4 N control 5 B control 6 O control 7 W quote run. Rainbow. The W didn't print. Oh well. Back to that. In the previous example, when you held down control and typed a 3, a euro or pound sign was displayed. Control 7 displayed a left arrow. Each color control will have its unique graphic code when used in this way. The table shows the graphic representations of each printable color code. Even though the print statement may look a bit strange on the screen, when you run the program, only the text will be displayed. It will automatically change colors and the color controls you place in the print statement. Try a few examples of your own, mixing any number of colors within a single print statement. Remember too, you can use a second set of text colors by using the Commodore and number keys. All right. Let's do a little example, shall we? Honestly, here, wait. While I'm focusing on this, so we have a bunch of colors displayed. I don't know if we can maybe change the filters on this to make it look just a bit better, maybe. Like color correction. Okay. You can mess with the gamma. That's wrong. That's fine. Okay, the contrast, let's see what that does. Yep, that's also fine. The brightness, yeah, that's also fine. Saturation. Okay, the saturation actually is helping a bit. Bringing it just a bit past that. Okay, then there's hue shifting it, which we definitely don't want, although... Yeah, I don't think we want to hue shift it at all. And there's opacity, color multiply. Okay, so color correction is not what we want. I wonder if also there's like, if we can sharpen the image a bit, will that make it look better? No, in fact, it looks pretty substantially worse. Because I'm just trying to make the eye, which looks red on my screen, trying to make it look better, but it's not working. And oh wait, properties, Yeah, discard. Filters, delete the sharpen, yes, close. And honestly, wait, properties, maybe there's a better format. BGR3 emulated, U12 emulated, YV12 emulated. Nope, didn't change anything in the quality. Resolution, leave unchanged. Frame rate, leave unchanged. Color range, full, limited, default. Okay, sure. Use buffering. Yep, okay, that all looks fine. That all looks fine. Okay. Well, resolution, maybe the resolution, I need to auto set it to this. No. Okay, well, I guess it's just stuck with the quality that it's at. Not a big deal. Okay. New program. 10 print CHR $147 close paren colon remark. Why do we want to remark? Oh, that's what the key is. Okay. Clear home. 20 print CHR $30 semicolon open quote CHR $30 changes me to question mark. Run. Changes me to green. CHR 30 changes me to. Oh, that's what it displays. The text should now be green. In many cases, using the CHR function will be much easier, especially if you want to experiment with changing colors. The following program is a different way to get a rainbow of colors. Since there are a number of lines that are similar, 40 through 110, use the editing keys to save a lot of typing. See the notes after the listing to refresh your memory on the editing procedures. Okay, so cursor up to position the cursor on line. Okay, yeah, so here, type 5 through 40 normally. So 1, rem automatic color bars. 5 print CHR $147 rem CHR $147 equals clear home. Line 10 print CHR $18 semicolon. What is that? 1, 2, 3, 4, 5 spaces semicolon colon rem reverse bars 20 CL equals int 8. It is an 8, right? Yep, 8. That looks really bad for y'all. What is it? Control or 7. Well, I can't go back and change what I've already written. I might be able to do that. Okay, 8. There you go. Times R&D 1 plus 1. 30, that's 39. 30 on CL. Go to 40, 50. Let's remove the spacing. 40, 50, 60, 70, 80, 90, 100, 110, 40 print CHR $5. So I don't know what character that is, but we'll learn. Go to 10. All right. Okay. Editing notes. Use the cursor up key to position the cursor on line 40. Type a 5 over the 4 of line 40. Next, use the cursor right key to move over to the 5 in the CHR parentheses. Hit Shift, Insert Delete to open up a space and type 28. Hit Return for the cursor on the line anywhere. Display should now look like this. Don't worry, line 40 is still there. Okay, so continue to modify it to look like this. Okay, not a big deal. All right. 60. We want it to say 30. On 70, we want it to say 31. On 80, we want it to say, what is it? Shift backspace 144. On 90, we want it to say 156. And on 100, we want it to say 158. On line 110, we want it to say 159. And then I think that's the program. Okay, so list the program to make sure all the lines are as we said. And yep, let's just compare. Rem automatic color bars 5, print CHR 147, rem CHR $147 equals CLR, yep, whatever. 10, print CHR $18, semicolon, space, bunch of spaces, semicolon, colon, rem reverse, whatever. 20, CL equals int paren 8 times RND, paren 1, print paren plus 1. Okay, and then 30, on CL space, go to 40, 50, 60, 70, 80, 90, 100, 110, and then 45, and let's just make sure that's right. 45, 50, 28, 60, 30, 70, 31, 80, 144, 90, 156, 100, 158, 110, 159. Okay, I guess let's run it. See what it does. Okay, so there we go. And actually, this is going to be, that's actually a good little screen. Because maybe we can actually go back to our filters and apply some color correction. Because that just doesn't look right, does it? Should bump up the saturation a bit. Okay, that actually does help a lot, actually. It looks way more like what I have on my screen. Okay, yeah, that looks great. It makes the red much more vivid. Okay, yeah, awesome. Sure. Add another filter. I would like to sharpen after the color correction, maybe. Does that help at all? Doesn't not help. Whatever. Okay. Well, cool. We did some nice color correction. But that said, it's still a bit hard to read certain things when I'm in a font like green. So maybe we do add another filter. Maybe do adjust the sharpness a bit. Did that even help? You can kind of see it, but it looks real bad. Maybe I sharpen it and then like blur it. Is there a way to do that? Luma key, image mask blend, HDR tone mapping, crop pad, color key, color correction, apply lut. No, none of that. Okay, well, you know what? I will leave it with a little bit of sharpness. And okay, that looks a bit better, but let's just do our little color display. And with that, I think we're gonna go ahead and call it. I think we've been streaming for what, about 2 hours now. That's my goal on these Monday and Wednesday streams. If you tuned in, glad you did. If you're watching the VOD, hey, glad to have you here. Anyways, I think that's going to be good. We made some good progress in the Commodore manual. So yeah, thanks for tuning in. This has been Coding Orangutan.